All right, so now we are at a point where we can build up the so-called unit circle, which is kind of like I would like to describe it as kind of the big gun of trigonometry. That people walking away from trig, they may not remember all of the details of everything, but they do remember the unit circle, both what it is, and they're able to draw it out. I should say they should be able to. For sure, anybody walking away from a trig class at the very end should be able to write out the unit circle. Maybe they don't have it memorized. Maybe you don't have it memorized. That's normal. That's fine. But you should be able to think your way through it and be able to replicate the unit circle. So the reason I say that is we're gonna go through. We're gonna fill in all of the details of the unit circle. I kind of already have it here, and it's something that you'll want to start memorizing now, or finding ways to remember it. Not that you necessarily have to remember every single little detail. For me, all that I really did is I memorized this first quadrant because things sort of repeat. So I'll show you what I mean by that and exactly what the unit circle is. At the end of the day, the unit circle is really just kind of like a quick reference guide for the evaluation of trig functions given standard angles or standard triangles, which I mean triangles that are right triangles that have either a 30-degree angle or a 45-degree angle in them. The unit circle also lists out what I might call so-called degenerate triangles, which is really not a triangle at all. It's just a line, and those are the triangles. I'm putting it in quotes. Those are the triangles that fall on the quadrantal angles. Which again, it's a degenerate triangle. You could think of it as being a multiple of both 45 and 90. 90 is the least common multiple of 30 and 45. Okay, so in any case, what we're doing with the unit circle, what I have right here, I have the standard XY plane, Cartesian plane, and then I have drawn a circle on here, and we want to assume that this is a circle of radius 1. That's why we call it the unit circle. When people talk about a unit in math, they often are talking about 1. So the unit circle means a circle of radius 1 where its origin is at the center. So that's what I have right here. And then I've put some tick marks on here to represent angles of elevation that might be formed by theta. So like right here, here's a 30-degree angle from the origin. Here's a 45-degree angle, 60-degree angle. And what we want to do is we want to use pretty much everything that we've put together now to specify what the coordinates for these points would be on this circle. Because remember, this is an XY, this is the Cartesian plane, an XY plane. So every single one of these points has some XY coordinate, and we want to list those out. And it turns out that we can use our special triangles to do that. So I have all of my angles ticked off and labeled. Very first thing that I want to do just for the practice is translate each of these angles into radians. Radians is really kind of where you want to move towards, at least from a math perspective, a theoretical math perspective. It's more common for angles to be written in radians. That's a bit more standard. I don't know, maybe if you get towards more applied fields, physics, engineering, things like that, maybe it is more customary for them to use degrees rather than radians. I don't know. But in math, it's pretty common, theoretical math, it's pretty common to just translate everything into radians. And usually as you get further into a trig semester or a trig course, things just start being displayed in radians. Just all the time. I think that we kind of just use degrees at the outset here because most of us have a more intuitive understanding of degree measures. We intuitively, like in our head, kind of know roughly what a 30-degree angle looks like, or a 45 or a 60 or a 90-degree angle. But for most people who are just getting into trig, if you talk about a pi over 3, an angle of pi over 3, they might not know immediately. There's a little bit of translating that you have to do. Okay, so we'll start at 0 and we'll move all the way around. Obviously 0 degrees, that's the same as 0 radians. 0. 30 degrees is pi over 6. The main identity that you could use to derive these, by the way, is the fact that 360 degrees equals 2 pi radians. Divide both sides. This is an equation, so we can manipulate it. Divide both sides by 2, 180 degrees equals pi radians. So 30 degrees is 180 divided by 6. So from this, 30 degrees is pi over 6. That's how you can kind of translate all of these. 180 degrees would be pi over 4. 180 divided by 4 is 45. 180 divided by 3 gives you 60. So that's how you can kind of derive these. So 30 degrees, that's the equivalent of pi over 6 radians. 45 is pi over 4. I'm just going to kind of fill these in rather than like talking your ear off, because you can just use these right here if it's tough, or you can also just use multiples. Once you have these ones, it's everything else is just multiples. 90 degrees is pi over 2 radians. Let's see, so if 60 degrees is pi over 3, 120 degrees must be 2 pi over 3. 135 is 3 pi over 4. 150, 5 pi over 6. 180 degrees, we have that right there. It's pi radians. Then, oops, 210, I guess I spit on my paper a little bit. Sorry, that's disgusting. 210 degrees would be, let's see, this is 6 pi over 6. Add on another pi over 6, 7 pi over 6. 4 pi over 4, 5 pi over 4. 3 pi over 3, this must be 4 pi over 3. 270 degrees would be 3 pi over 2. Right, 300 degrees is 5 pi over 3. 7 pi over 4 is 315 degrees, and 11 pi over 6 is 330 degrees, and then we're back to where we started. 2 pi is the same as 0 degrees, is the same as 360 degrees, the way that we've listed this all out. So these are the radian measures, along with our corresponding degrees. And now what we're going to do is we're going to just list off what each of these coordinates on the coordinate plane must be. And we'll start with the easy one, 0 degrees. Well, since it's on the x-axis, the y-coordinate is 0. And remember, this is a circle of radius 1. So this distance right here must be 1. So the coordinate here is 1, 0. Next comes the 30-degree angle. And again, we're assuming that the radius, so the distance from the origin to this point, is a distance of 1. The hypotenuse is 1. That's why we can use these special triangles, because we're assuming that the hypotenuse is 1. And these tell us exactly what the x and y coordinates are. This is saying that at a 30-degree angle, if the hypotenuse is 1, the x coordinate is root 3 over 2, and the y coordinate is 1/2. Just like that. 45 degrees, well, the x coordinate is root 2 over 2, the y coordinate is root 2 over 2. 60 degrees, we're still using this same triangle, but now it's kind of reoriented so that the 60-degree angle is at the origin. So this flops the x and y coordinates from the 30 degrees, so this is 1/2 comma root 3 over 2. And then up here at 90 degrees, now we're on the y-axis. A distance of the radius is 1. X coordinate is 0, so this is, 0 comma 1. And then now, this is the reason that I was saying that once you have this first quadrant all kind of listed out, it gives you the other quadrants, because circles are symmetrical. So this point right here, this 120 degrees, this is the mirror image of our 60 degrees just mirrored over the y-axis. So it's going to have the same coordinates, with the caveat that now the x coordinate is negative, right? Over here, this x coordinate would be negative, the y coordinate is positive, so it must be negative 1/2 comma root 3 over 2. And it's going to be the same thing here. This 135 degrees is mirrored from 45 degrees. The x-coordinate is negative. Negative root 2 over 2, comma, root 2 over 2. And then here, negative root 3 over 2, comma, 1/2. At 180 degrees, now this coordinate is negative 1, comma, 0. And then same deal, 210 degrees, well, this is just mirroring 150 degrees, mirroring 30 degrees, but now both x and y are negative. So this must be negative root 3 over 2, comma, negative 1/2. Then negative root 2 over 2, comma, negative root 2 over 2. Negative 1/2, comma, negative root 3 over 2. 270 degrees, this is the coordinate 0, comma, negative 1. 300 degrees, this would be the equivalent of, let's see, the reference angle here would be 60 degrees. So this is 1/2, comma, negative root 3 over 2. 7 pi over 4 is positive root 2 over 2, comma, negative root 2 over 2. And 11 pi over 6 is positive root 3 over 2, comma, negative 1/2. So that's the unit circle. And this tells you essentially, it just gives you what the trig functions evaluate to at these various angles. So something like, if we were asked what is the sine of, say, 11 pi over 6. So sine designates the y-coordinate on the unit circle. So the y-coordinate at 11 pi over 6 is negative 1/2. Another one, maybe, what is the tangent of 210 degrees? So 210 degrees is right here, 7 pi over 6. So this is equal to, and tangent is y over x, or opposite over adjacent. So negative 1/2 divided by negative root 3 over 2, which becomes positive 1 over root 3. So rationalizing, it's positive root 3 over 3. So yeah, this is kind of just like a quick reference guide for solving some or evaluating trig functions given a standard angle, meaning a 30 degree angle, a 45 degree angle, 60 degree angle, 90 degree angle, whatever the case is. Yeah, I guess let's do a multiple of 90. So let's do what is maybe the cosine of pi over 2. Here's pi over 2. Cosine designates the x-coordinate. The x-coordinate is 0. So cosine of pi over 2 is 0. All right?